Welcome, ladies and gentlemen, to today's presentation. Before I proceed to today's presentation, let us recap what we have learned in the previous lectures. In the previous lectures, we discussed about the four disciplines of spatial data science. That is the geographic information system, spatial database management system, spatial data analytics, and big data system. These four disciplines are very important to master to be able to be called a spatial data scientist. And I presented appropriate open source software for each discipline. If you've not watched the video, kindly look at the description part of this video to have access to a link to watch it. And also, kindly subscribe to my channel if you've not subscribed yet. In this lecture, we will discuss about spatial data science problems. I will categorize spatial data science problems into 6 groups in terms of solution frameworks. As shown in the slide, 6 problem types are desktop GIS, server GIS, spatial web, spatial data analytics, spatial data management and analytics, spatial big data management and analytics. For each problem type, I will explain how the solution framework can be used. Spatial data science problems could be simply defined as problems associated with where for either the input data or output results or both. Examples are: where is the best place for a new restaurant in Accra, Ghana? What is the emotional condition based on his or her trajectory now? We do not have a clear answer to the questions yet, but it will be very meaningful question in mobile IT companies or business. If you have reliable solution, Microsoft or other major IT companies will buy and use it for their personal assistant. For example, Cortana for Windows 10. The first category of spatial data science problem is named as desktop GIS or single user GIS. As mentioned before, GIS can deal with almost all aspects of spatial data science so that it can handle spatial data science problem by itself. Spatial data science problems with desktop GIS will be characterized by the following. First of all, data size is relatively small and only single user is assumed. In other words, a standalone application. In terms of level of analysis, desktop GIS can deal with basic spatial analysis only. The main focus will be placed on mapping and geovisualization. The second category is named as server GIS or multiple user GIS. It uses GIS and spatial database management system. The major difference from the desktop GIS will be data size and data management issues for multiple users. So that server GIS can be characterized by the following. Data size is generally bigger than desktop GIS, for example, of 100 megabytes, in order to support multiple users. Full functionality of database management system should be supported, such as transaction management with atomicity, concurrency, isolation, and durability, SQL and data indexing and query optimizations, and so on. Main focus will be placed on data management with database management system and mapping geovisualization with GIS. The best example will be a server GIS for the local government. For example, country governments in Ghana, they generally have quite few spatial data in-house for their operation every day. cadastral data of parcel boundary and ownership, certified surveying maps, zoning data for land use planning, tax roll for taxation, utility layers such as water supply and sewage, parking and transportation, and many others. The datasets should be well managed in database, and individual departments should be connected to those spatial database management systems and conduct their works and operation with GIS. The focus will be data management with database management system and mapping and basic operation with GIS. The next type is Spatial Web or Web GIS, which is also known as web mapping, which is the process and application of making spatial data dissemination. Simply put, Web GIS is a pattern or architectural approach for implementing a modern GIS. It's powered by web services, the standard services that deliver data and capabilities and connect components. WebGIS can be implemented in the cloud using ArcGIS Online, on premises using ArcGIS Server, or more typically as a hybrid combination, leveraging the best of both worlds. WebGIS isn't new. In fact, it's been evolving for a long while, but we have actually passed a tipping point where innovation in GIS and related technologies have made WebGIS not only possible, but essential. WebGIS brings GIS into the hands of the people. It reduces the need to create custom applications. It provides a platform for integrating GIS with other business systems and enable cross-organizational collaboration. WebGIS allows organizations to properly manage all their geographic data. Geographic information system has the potential to go beyond mapping GIS after diverse set of analytical functions. The emergence of WebGIS unlocking the power of GIS to a wider audience, helping in decision-making process. WebGIS rely on Java, Netflix, and run on multiple platforms. 2. Supports a large number of users simultaneously. WebGIS relying on HTML client supports different operating systems, better cross-platform capability. However, WebGIS for mobile clients is far from being cross-platform because of the diversity in mobile OS and incompatibility of mobile web browsers. Easy to use for end users, compatible with different web browsers, Google Chrome, Internet Explorer, Firefox for diverse OS, Win, Linux, Mac OS, and iOS. Undefined system update offers chunky demographic datasets and imagery map layers, which allow users to access immediate context from different applications. Customization dashboard with a user-friendly interface. The WebGIS has a diverse range of applications. Some of uses are listed below. Mapping, stroke visualization and query, attribute or spatial collaborative collection of geospatial information, geospatial analysis, measurement, optimal driving path, routing, pollution, dispersion modeling, retail site selection. WebGIS as a new business model and a new type of commodity, location-specific advertising and branding based on mapping. GIS application is an engaging and powerful tool for designing and planning government projects like flood management, forest management, mapping, and natural disaster. WebGIS technology is used in geoscience research collaboration. WebGIS Daily Life, a location-based service supported by mobile web, smartphones, and tablets. LBS involving service to identify a location of person or objects, such as discovering the nearest ATM, restaurants, shops, and hotels. Also include parcel tracking and vehicle tracking services. The next type is Spatial Data Analytics. GIS can deal with geoprocessing and basic spatial analysis, but it has limited analytics power. For example, very limited functionality for statistical analysis. In case you need to conduct advanced spatial analysis, it is required to connect the GIS with data analysis tool. In our framework, QGIS for GIS with R for data analytics. Spatial data analytics problem can be characterized by the following. It has relatively small data sets for single user so that GIS can deal with it. Main focus must be placed on flexible and advanced spatial data analysis. Mapping and visualization is also important. A simple example is statistical analysis with spatial data. The next type is spatial data management analytics. This type can be characterized by the following. The data size is generally large and it has multiple users. For that, full functionality of database management should be supported. Main focus should be placed on both spatial data management with database management system and advanced spatial data analytics with data analytics tool. The next type is entitled as spatial big data management and analytics. Big data systems such as Hadoop, HBase, and Prime language like Java and Python deal with pre-processing and refine the big data in order to make the data stored in spatial database management system or conduct direct analysis of the Hadoop ecosystem. Spatial data science problem in the type can be characterized by, first of all, big data science at a minimum of 100 gigabytes, and then data management with database management system and flexible and advanced analysis. And mapping and geovisualization are all important. All right, this is the end of this lecture. Thank you for your attention and see you in the next lecture. Before you go to the next lecture, kindly subscribe to my YouTube channel to help push me. Thank you.